Okay, so from now we're going to be discussing about crystal structures. So, like materials, crystal structures, they sort of seem related, sort of not. You think that this would be something part of geology or something like that, like rocks and crystals and stuff. But then if you think about it a little bit further, kind of makes sense how if you get like rocks, then you can like kind of refine them into like minerals and metals, and then like metals, crystals, kind of like makes sense. So the reason generally why we study like crystal structures is generally in regards to metals, um, because metals can take on different crystal structures, and these crystal structures can affect their properties. Um, Understanding these crystal structures can play a pretty important part in how the properties of materials develop out of them. Different crystal structures affect different properties like strength, hardness, and where it's weaker and where it's stronger. It's maybe in certain directions it's more likely to like give way, whereas different directions it's not. And we'll get into each of these like in more depth in the upcoming videos. So in regards to the main crystal structures that we talk about, generally a crystal is like a repeating pattern of like atoms layout. That's like an important thing about metals. They always, well, almost always, come up in repeating patterns of the same thing over and over again. So um, the the main types of crystal structures that's just covered in the course um, is first we got ourselves this is pretty rare structure, but we get a simple cubic structure. All of these are given acronyms because everyone's lazy. I mean, not really lazy, but just it's convenience. SE. The way that a simple cubic tends to look like is like this. So yeah, you can imagine just each of these spheres as one atom. Yeah, so I can just select different atoms, but yeah, so you sort of see how this tends to look like. Yeah, so simply just 8 atoms. But you can imagine this as kind of repeating on. So after this, you can have like an atom further down here, an atom down here, cross, and so it's like simply like just laid up one on top of one another. This is a pretty rare, like a pretty rare layout because sometimes, an atom can like fit in this hole here, and so it could have like a different setup. So getting back, so that's how a simple cubic looked like. The other way that I can draw this up, just so you can picture it, is one to just like the way that you regularly draw, yeah, regularly draw just a cube. So that's just simply a simple cube. So yes, it's a cube, so everything is like same lengths, and all the angles are 90 degrees. So say if I'll indicate all the atoms with a red dot. So these are all like metal atoms. Again, this is really rare to pop up as like an actual crystal structure like in real life. Yeah, okay. Yeah, it's really rare for this to pop up in real life, but this is just a crystal structure, so like for your understanding. Okay, so enough rambling. Let's go for the next one. We got a base center cubic. Sorry, not base, body centered cubic, and then structure. But yeah, so body center cubic, BCC acronym. Okay, so it's basically the same as a simple cubic, but the thing is that there's an atom in the center of the entire cube. You notice in this one, in our simple cubic, where all the atoms are touching one another, like nice and neatly. This doesn't exactly happen for the body center cubic. So here, you notice that there's a gap between atoms across, and that all the atoms are touching, but like it's the middle, that's touching all four, and it's kind of like at a 45-degree angle, is like perfect square. Um, and like looking from the top, it's also like nice, wholesome, perfect square. You can imagine this just being extended for, I'll open another file where, forget that same part, multiple. So take a look at this. So yeah, so this is like, imagine like this recurring over and over for like other directions as well. So because it's a crystal, it's not like just one like few set of atoms, but like you have like a whole bunch. So this is how a BCC or body-centered cubic look like. So you can imagine like one cube, and out of like each little cube, there's like one atom in the middle. Yeah, so that's how that repeating structure looks like. Next up, wait, actually no. Yeah, so that's how body-centered cubic looks like. I'll just draw up the atoms. So there's an atom in each corner. Recap. Atom in each corner. And then there's an atom like right in the middle. That's okay. I'll put like a different color for that. Yellow. So the yellow atom's also in the middle. Yeah. So each one is in the corner and one in the middle. The next one we got there's a few. It's called a face-centered cubic. So body-centered is in the middle of the body. Face-centered, take a guess. Yeah, okay, it's in the face. Pretty much duh. So in the middle of each face, you have an atom. So I'm just going to draw like ourselves a basic cube. Yeah. So how a face-centered cubic looks like. Let me open up the file. Get the saves. Let's get one of them. So this is how a face-centered looks like. So you see like in the corner you have like the regular, like each corner has an atom, and then the middle of every face has an atom as well. Yeah, so the middle of every face has one more atom. Yeah, kind of like pretty weird how all of these are like sort of transparent, but you should be able to get the idea. Yeah, so this is how a face-centered looks like. If you want to see like all of them like clustered together. Yeah. So here, we have multiple of these. So this is just a bunch of face centers. So you can see like one cube here and then the face center. And then you can also see that recurring pattern happen again and again. So that's what makes this a crystal structure. Yeah. So that's a face centered cubic. Looks pretty cool. Yeah. Kind of hypnotizing in some way, but yeah. Yeah. So a face centered cubic, as we said before, one atom in each corner, and one atom in each face, on the middle of each face. This one's in the middle. Actually, what I'll do is all the face centers, I'll put it like a different color, but they're all atoms, like of the same thing. So I'll go pink. So pink is the middle of this face, the front face, the top face, side face, bottom face, the other side face. Okay, and then there's like one more face I'm missing. I think like the back face. Yeah. So 6 pink, 8 thing red. But yeah, so that's how a face-centered cubic looks like. There is one more, which is known as the hexagonal. So they're not all cute. Hexagonal. Close packed. Structure. Yeah. HCP. Yeah. The way these look like is like a hexagonal prism, where I haven't actually got like a 3D view, but please imagine. So it's just like a hexagonal base, hexagonal prism. Go red for each of these. 1, 2, 3, 4, 5, 6. Yep. Okay, and then you also got, I forgot the last one, but so you got, yeah, up on the top you also got 6 more. Clearly I cannot draw straight lines. Let's draw 6 more, the last one over there. So. And then right in the middle, you also have another 3. Because atoms find it convenient. When atoms find it convenient, you just go with it. Yeah, so another 3 nicely fit together. And so this kind of goes recurring upwards and then sideways. Is like, if you look from the very top, it looks like a hexagon, and hexagons can like tessellate. They like fit together perfectly. So between those hexagon layers, then you have the triangles. It's pretty much just that. So these are the crystal structures that you're generally going to be faced with in this course.